Hi everyone, this is John from Civil Center. Welcome to our channel. As we know, Civil Center is always there to guide you, and to do so, we keep making videos on different topics that are related to civil engineering field. So, what are we going to learn today? Today, we will learn what is the difference between tie and stirrup. So you can see we have two images over here. One is of beam and the another one is of column. And you can see in both the beam and the column we have a reinforcement around the main reinforcement that is holding the main reinforcement. So if you are using this bar in the beam, then it is known as stirrup, and if you are using this in the column, then we call it as tie. So tie is a tension member which resists the axial force. Now the question is, what is axial force? So the force along the longitudinal axis is known as axial force. Now let's see the definition of the tie and the stirrups. So you can see over here, a tie is a linear structural component designed to resist tension. So how is it resisting the tension? We will discuss about it. Then our next point is it is opposite to a strut or column which is designed to resist the compression. Now let's go back to the image, and this is our column. So you can see that this is resisting the compression. Why so? Because if you are having a structure like this, so this is our, suppose the ground level, and then we have two columns over here on which a beam is resting. So the force on the column is applying in this direction. So obviously this column is resisting the compression force. So this is our column over here, and this is resisting the compression force. Now what will happen if we will apply the force in this direction? Then this column may buckle either in this direction or in this direction. And to avoid that buckling, we provide ties over here. So what is the main purpose of these ties? These ties hold the main reinforcement in place so that we can resist the buckling in the column. Even the stirrups does the same thing, but it avoids the bending moment. So let's see how it do so. So suppose this is your beam. Okay. Now if you will apply a load over here, then this will buckle in this direction. So to avoid the bending moment, we provide the stirrups in our beam. So the main reinforcement will be along this direction, and then you will provide stirrups so that it can hold the main reinforcement and avoid the bending in the beam. Okay, so I guess these 2 points are clear. Now let's go to the next point. So ties may be made of any tension resisting material. Why so? Because it is resisting the tension. So I will explain you for one more time. So these bars would have been bent in this direction, okay, or in this direction. Then we provided the ties over here, and that's why these ties are holding this. That means if this main reinforcement will try to buckle, then there will be a tension force over here, and these ties will hold this. That's why you can say ties may be made of any tension material because it is resisting the tension force over here. Now let's sum up what we have learned so far. So we have ties over here. So a tie do not take or share any part of the load coming on the column. The ties are evenly spaced along the full height of the column. That means it will not share the load of the column, but it will definitely resist the axial force in the column. Then we have the stirrups. The term stirrup is used to define the transverse reinforcement provided in a beam where the primary mode of the load transfer is through the bending or shear. That means you can call the stirrups as the transverse reinforcements, and the work of it is to hold the main reinforcement and to counter the bending moment and the shear force that is being generated in the beams. So guys, I think all the points are clear so far. If you have any suggestion or any topic on which you want us to make video, then you can suggest that in the comment section and we will definitely make a video on that topic. So till then, take care. Bye bye.